to week 5. This is April 27th, and we're going to the beginning of May. We are still talking about atmosphere in this week, and we're going to start talking about how clouds form. We're going to do a little background information first. So we're still looking at properties of the atmosphere. So we're looking at humidity, which is how much water is in the atmosphere. If it's a very humid day or it's a very dry day. Think about when your hair is staticky in the middle of winter. It's not the same as when you're outside in July when it's hot and humid. We can measure humid two ways: relative humidity and dew point. Relative humidity is going to be the amount of water in the atmosphere compared to how much it could possibly hold, and we write this as a percent. And dew point is the temperature at which water vapor condenses to water. So, and that's expressed as a temperature, and that's more of an absolute value. So if you're looking at these bottles that are here, why do they look sweaty? And the reason they look sweaty is there is water vapor that is touching the outsides of these cold bottles, bringing down the temperature of that water vapor until it hits its dew point. And then all these droplets of water here are where the water vapor has condensed to water. That's why your mom tells you you always have to use a coaster on your coffee table so that you don't wreck it. Then if we look at this example, you can see two containers. Here's container A and here's container B. And they're representing air. So if we have air at 21 degrees Celsius, 21 degrees Celsius is like 70 degrees Fahrenheit. And we have air at 38 degrees Celsius, which is 100 degrees Fahrenheit. Much different temperature. So, but you can look here, the relative humidity on both of them is the same, 50%. So if we have relative humidity here at 50%, ooh, can't read that, and here at 50%. Do you think those two temperatures would feel the same if it's 50% relative humidity at 70 degrees versus 50% humidity at 100? It's going to feel way worse. So how relative humidity isn't a great indicator of how humid or muggy the air is. A better indicator is your dew point. And the dew point here is at 10 degrees would be 50 degrees Fahrenheit. And at 26 degrees would be 82 degrees Fahrenheit. And when those dew points get up, into that 70 and to 75 and up into 80s, it feels terrible. So this temperature with that amount of water in the air is going to feel much muggier than this temperature over here. So even though you can see that they're both 50%, if you have air that is 100 degrees versus air that is 70 degrees, air that is much hotter is going to be able to hold a lot more water vapor than air that is cooler. All right, so what you're going to do next is you're going to watch a couple of videos and answer a couple questions looking at this exact same thing. So that's the first assignment for this week for Earth Science.